Yes, good morning. Welcome to today's session on oscillations. It is one of the important topic in UPSC, NDA, NCET, IIT, JEE, CUT, other competitive examinations. So, without wasting the time, we move with fundamental concept. Then after we will do combinedly 25 MCQs which are most important for any examination. Okay, shall we start? Okay, thank you. So, what is oscillation? Before oscillation, we need to discuss about what are the motions, what are the types of motion. See here, generally, as per this particular chapter, we have to discuss about what is meant by periodic motion. After that, we go for oscillatory motion. First of all, what is meant by periodic motion? The motion, the motion that repeat itself after a regular interval of time, after a regular interval of time. This is known as periodic. Periodic means what? Repeated. Here periodic motion means the motion that repeats itself after a regular interval of time. A regular interval of time. That is known as periodic motion. Then what is the example of the periodic motion? The example of the periodic motion, as we know, our earth revolving around the sun. Earth is revolving around the sun. Similar way, around the earth, moon is revolving. Moon is revolving. So this type of the motion is called as periodic motion. Earth is revolving around the sun. Similar way, moon is revolving around the earth with a regular interval of time. This is known as periodic motion. This is known as periodic motion. If you go for a graph, if you want to express this one in graphical method, then we will consider, that is, on y-axis, x-axis. On x-axis we will consider periodic motion character. Here it is about the displacement. How do you consider periodic motion character? So this is about periodic representation. In the graphical method, how you represent periodic motion. So this is about time t, this is displacement, and this is for the visualization of periodic motion. So here 0, time t, time 2t, time 3t, and so on. See, there is only equal time interval of time, So this is about displacement. So this type of the presentation we will consider as periodic motion. Okay, clear? You may understand, I think so. This is nothing but a graphical representation of periodic motion. Now, what is oscillatory motion? What is oscillatory motion? So here oscillatory motion is nothing but to and fro motion. To and fro motion about a mean position, about a mean position, about a mean position is called oscillatory position. Sorry, oscillatory motion. About a mean position, about a mean position is known as oscillatory motion. To and fro motion about a mean position is called oscillatory motion. Clear? So what are the examples of the oscillatory motion? You can see guitar. The strings of a guitar is oscillatory motion. Swing is a oscillatory motion. Swing is a oscillatory motion. And one more thing, simple pendulum is example for oscillatory motion. So here swing, simple pendulum, both are an example of oscillatory motion. Oscillatory motion is also considered as vibrational motion, but when if the frequency is high, then that is called as oscillatory motion. So that is called high frequency of oscillatory motion, that we call as vibrational motion. So here oscillatory motion is equal to vibrational motion. Vibrational motion when oscillation motion is having low frequency, where vibrational motion is having high frequency. So this is oscillation motion is equal to vibrational motion, but oscillation motion will stick to the low frequency, whereas vibrational motion is stick to the high frequency. Okay, now there is a note. What is that note? All oscillatory motions, all oscillatory motions are periodic. Oscillatory motions are periodic motions. All oscillatory motions known as periodic motion. But what? All periodic motions not equal to oscillatory motions. Clear? All oscillatory motions are periodic. Oscillatory motions are periodic, but periodic is not oscillatory. Periodic is not oscillatory. That you need to remember. This is important aspect. So we discuss about the mean position. So what is mean position? If you take simple pendulum, this is called as mean position, and here this point and this point is known as extreme position. A and B are known as extreme positions, whereas C is known as mean position. At extreme position, while it is moving upward, kinetic energy velocity is decreasing. What is that? Velocity is decreasing, so kinetic energy also will be decreasing, even though at point B. While it is moving from C to B, velocity is decreasing, so that kinetic energy also decreasing. It is at extreme point, it is 0. Here also it is 0. But at mean position, the kinetic energy will be high, that is about maximum. Here kinetic energy 0 means potential energy is high. Similar way, at point A, kinetic energy is minimum and potential energy is max. So that is about, we can consider energy conservation. How energy is conserved. Velocity decreasing toward the extreme position, so kinetic energy is decreasing, it is going to be 0. So that is with respect to simple pendulum character. That's about the how energy vary in oscillatory motion. Oscillation motion can be represented by sine function as well as cos function. Sine and cosine, you can also consider cosine. Sine and cosine with a periodic of 2 pi. With a periodic of 2 pi. With a periodic of what? 2 pi. Okay, clear. Now sine curve, how we represent in terms of sine. So this is about sine representation for the periodic. If you are using sine term, so this is the best representation for the, this is t and this is displacement. Okay, clear. Then if you go with the cosine, then it will be start from here. So this is about the sine representation, this is about the cosine representation of the periodic motion, sorry, accelerated motion. See here, it started 0, here it started somewhere, at instant it is at 0, origin is 0, origin is at instant, the starting position at an instant, here the starting position at 0, that is we need to remember. Okay, clear. Then after that, what is simple harmonic motion? So here SP, simple harmonic motion, simple harmonic motion, SHM, to and fro motion, to and fro motion, to and fro motion of a body, to and fro motion of a body or a particle, one body or a particle which execute to and fro motion about a fixed or about a mean position, about a, this is best word, about a mean position, to and fro motion about a mean position is called simple harmonic motion. To and fro motion of a body or a particle about a mean position is known as simple harmonic motion. Simple harmonic motion. Oscillation with very small amplitude. Oscillation with very small amplitude. Small amplitude. Small amplitude means what? Displacement, maximum displacement from mean position. So oscillation with very small amplitude can be treated as SHM. Can be treated as SHM. Small amplitude oscillated motion. Small amplitude oscillated motions can be treated as SHM. Simple harmonic motion. Clear? Simple harmonic motions. So here you can take one spring, it is attached to a base, we added something at the extreme position, then it executing about a mean position, it is executing to and fro motion, to and fro motions. Here this spring, when you pull down, it is moving this side. When you remove the force, it is coming to this side. When you apply the force, you are pulling this black. When you are applying the force, it is extended to this side. When you remove this force, it is again extended to this side, and this is because of the restoring force. What is that one? Restoring force. How much force you applied on this block, that much of extension, that much of the displacement we can observe. So that the force is directly proportional to displacement. Force is directly proportional to displacement. So that here we can take, when you remove this proportionality, but in what direction? The object want to move to this side, but you are dragging this side, so that is the reason we are using F is proportional to minus X. We are using opposite side of negative, because you apply the force that side, the spring want to move towards left side, so that is the reason. You are dragging right side, the spring want to move towards right side, so that is indicating minus symbol. So now when you remove this proportionality, when it is equal to one constant, that is equal to F equal to, we will consider one constant, that is F equal to minus kx. What is that one? Minus kx, where k is nothing but spring constants or force constant. This is called force constant. F equal to minus kx, and we know very well from Newton's second law, F equal to ma, then minus kx, then k equal to, then you keep, what is that, you keep a like that only, so minus k by mx. So what is k by m? As you know very well, k by omega square equal to k by m. Am I right? Omega square equal to k by m. So that we will consider here k by m, a equal to omega square x, and finally, sorry, a equal to omega square x. A is proportional, if you are consider this constant, then it is proportional to x. You can say that one. Acceleration is proportional to displacement. Force acts always opposite to displacement, so that is the we have minus symbol. Why we have minus? Force always act opposite to the displacement, so that is the reason we taken minus symbol. Is it right? So this is about the simple harmonic motion. Okay, I will give few more concepts, then we will start MCQ. So there is a differential equation for the simple harmonic motion, that is about the, I'm not going to derive this whole thing, just I'm giving something important topic concept for you. F equal to m, because if I go for the derivation it will take a lot of time, it is going to be a modern class, I don't want to be go with that one, just I will go with the important key points. So here differential equation of SHM is defined with m d square x by dt square. This is one of the formula for the force. So here based on this one we will consider differential equation d square x by dt square plus omega square x equal 0. This is known as differential equation. Differential equation for the SHM. Differential equation for the, what is that? SHM. Okay, clear? Then some keywords are also there. One is called amplitude. Amplitude, time period, frequency, angular frequency. Let's see what is amplitude. Amplitude is nothing but we have main position. From the main position is the wave is moves like this. So this maximum displacement we will call as the amplitude. The maximum displacement from the main position is known as amplitude. Maximum displacement from the mean position, this is known as mean position. From the mean position the maximum either positive direction or negative direction, either up direction or lower direction, this maximum displacement we call as the amplitude. Then Time taken for one complete cycle. Time taken for one complete cycle is known as the time period. Here the units are meters or centimeter. Here the units are second. Then frequency. The total cycles in 1 second. In 1 second, how many cycles are made? That is about the reciprocal of the time period, which is about the hertz. So that is frequency. Then angular frequency. Angular frequency is nothing but total number of cycles per the cycle we have to consider for 2 pi radians. Total number of cycles completed in one cycle, that is about 2 pi in terms of 2 pi. So that is omega equal to 2 pi nu RF. You can take natural frequency. This is about the angular frequency. This is about natural frequency. Angular and natural. So you can natural F equal to is reciprocal time period. So omega equal to 2 pi by t. So this is also one of the relation. So 2 pi nu or 2 pi t. Clear? Then velocity displacement expression. Let us express the sine function, wave function in simple harmonic. We will consider by what is that y displacement, that is y equal to a sine omega t, a sine omega t plus phi. Okay, clear? This is theta, just like you can imagine that is a theta. Okay, clear? Just now, just this is our displacement with respect to time, that is called velocity. Am I right? Dy by dt. I don't want to go with the more derivation. A sine will be changed to cos. This is just like omega t plus phi, but inside we have omega, so that is called a omega cos omega t plus phi. This is for what? This is for velocity. Similar acceleration, a equal to dv by dt. dv by dt. So dv by dt, this is for velocity. We can also consider one more step. Velocity equal to what we got? That is a omega cos of omega t plus phi. Am I right? So this we can write as a omega, as cos means what? I can sin theta. That is under root of sin square omega t plus phi. Am I right? 1 minus. Okay. What we got? V equal to a omega cos omega t plus phi. So now a omega as it is, cos means what? 1 minus under root of 1 minus sin square omega t plus phi. So a omega is as it is, 1 as it is. What is sin theta? Just we discuss is that y equal to sin a. Is it right? Y equal to we got y equal to what we got? Y equal to a equal c. Okay, wait. Y equal to a sin omega t plus phi. I want which one? Sin. That is y by a is right. Y by a. You can take here y by a whole square. So finally you will get what? You will get that is about a omega under root of 1 minus omega y square by a square. This is other derivation for the velocity. We can use any formula, either this one or this one. Okay, clear? Similarly, for the displacement after velocity after acceleration. So acceleration formula is about, I will take that one, alpha equal to minus omega square x. This is for acceleration. Okay, clear? So like that we have, so the total kinetic energy in SHM will be considered as one more formula, that is about 1 by 2 m omega square a square minus y square. This is total kinetic energy in SHM. Then what about potential energy? Potential energy in SHM will be considered 1 by 2 m omega square y. So this is kinetic, this is about the potential. And coming to total energy of the SHM, the total energy of the SHM will be considered as 1 by 2 total energy. Total energy of SH. I'm giving only key concepts because if I go with the derivation, it will take lengthy time, lot of time. So I don't want to take that much. I don't want even get you bored. So here total energy, that is sum of the potential and kinetic energy. The total energy is equal to 1 by 2 m omega square a square. And finally what you conclude that one, total energy is proportional to a square. Total energy is proportional to a square. And total energy is also proportional to omega square. Am I right? So you can take here omega is nothing but what? 2 pi f. So total energy is proportional to, in the place of f you can take omega, in the place of omega you can take also natural frequency. So that is about f square. So a square, total energy proportional to a square, total energy proportional to the f square, total energy proportional to omega square. If you go to the representation of the graph for the simple harmonic motion in terms of what is that? Potential energy and kinetic energy. Potential energy and kinetic energy. So this is a representation to express the total energy. So where is this midpoint? It is about the mean one, kinetic energy. Here extreme position you have potential energy as we discussed previously, extreme positions. So here this curve is about the kinetic energy representation. This is about the potential energy representation. Here it is -1, here it is positive displacement. So these are about the few things for the introductory concept for the what we have simple harmonic motion. In simple harmonic motion we have simple pendulum also. A simple pendulum is the best example of the simple harmonic motion character. What is simple pendulum? Simple pendulum, it is a, see, this is known as a simple pendulum. See, this is called string, lightweight string or thread. This is a metallic bob. A metallic bob is suspended with a thread or light or massless thread to a fixed point. And this body when you disturb, it makes to and fro motion, and that is called as SHM. This SHM time period, it depends on the time period of SHM 2 pi simple harmonic motion pendulum, that is expressed by T equal to pi under root of L by G. T equal to pi under root of L by G. So the time period depends on length, the time period depends on the G. Time period directly proportional to square root of length, time period is opposite to the square root of the G. So this is about the time period of a simple pendulum. If a simple pendulum taken 2 minutes, that is called a second pendulum. It is, sorry, not 2 minutes, 2 seconds, sorry. If the simple pendulum taken 2 seconds, that is called as the seconds pendulum. Seconds pendulum. When is second pendulum get? When the length of the string or thread of a massless is 1 meter length. If it is 1 meter length, that is called as seconds pendulum. The time period will be 2 seconds. So the laws related to the simple pendulum, first one is about the, that is law of isochronism. Laws of isochronism. And second one is about the law of length. Law of length. Law of mass. Law of acceleration. So these are the Four basic concepts related to the simple pendulum. First of all, what is meant by isochronism? Smaller amplitude at a given place. Smaller amplitude. Okay, smaller amplitude. Sorry, isochronism. Smaller amplitude at a given place time, at a given place the time period is constant. What is that? Time period is constant, provided that L and G also constant. So what is the meaning? All time period, length, gravity. If these all three are constant, then it is called as isochronism. Small amplitude. So this is about smaller amplitude. So here the three variables will be constant with respect to each other. That is called isochronism. Then coming to the law of length, T is proportional to root L. This is called as law. The time period of a simple pendulum is directly proportional to square root of length. That is about the law of mass. Law of length. Similarly, time period of simple pendulum not depend. Remember, this is a keynote. Not depend. Note. What is note? Time period of simple pendulum not depends on mass. Most important. That you have to remember. Time period of simple pendulum does not depend on mass. Okay, clear? Then law of acceleration. That already we know. T is inversely proportional to root G. The time period of a simple pendulum is inversely proportional to square root of acceleration due to gravity. So these are about the simple pendulum laws. Okay, clear? Next one, free vibration. Free vibrations are nothing but when a body is displaced from mean position without external force. From mean position, the body is vibrated or displaced about a mean position without the external force. That is called as the free vibration. No, that means no need to apply any force. Without any external help, the body freely vibrated. The body is freely moving, and that we called as the free vibrations. In the free vibration, the frequency is called as the oscillatory frequency or natural frequency, and that is represented by nu naught equal to 1 by 2 pi root k by m. This is for natural frequency equation. Natural frequency. Similar way, when we heard a sound that is gradually decreasing its intensity, similar way, when a wave is displaced, when a wave oscillated about maximum amplitude, later that maximum amplitude is decreasing, and this is called as the damped oscillations. What is that one? Damped oscillations. Okay, clear? Damped oscillations. So these are some terms, some concept related to this oscillatory motion. Okay, clear? Then let me reveal few more concepts. What I discussed just now, quickly I will go with it. Oscillations is a periodic to and from motion about a mean position is known as mean means what? Equilibrium position. Examples: simple pendulum, mass spring system, vibrating tuning forks are known as the best example of the oscillatory motion. SHM is the simplest form of oscillatory motion. Just now we discussed, and now I'm moving with the quick points. Then after we go for the 25 MCQs. SHM. What is SHM? SHM, simple harmonic motion. It's a part of accelerated motion, but this accelerated motion is the simplest form. And the key terms related to this simple harmonic motion is restoring force is proportional to displacement, which is nothing but F equal to minus kx. Similar way, acceleration is equal to minus omega square x, where acceleration is proportional to displacement. Motion is periodic with constant frequency. So this is about simple pendulum. This is called mean position. These are extreme positions. Okay, clear? And the graphical representation for the simple pendulum, this is about simple harmonic motion. This is the thing. So clear? So then the key terms just now we discuss here: amplitude, time period, frequency, angular, frequency. These are key terms for the oscillatory motion. Just now we discussed here. Maximum displacement from mean position is known as amplitude. Time for complete oscillation is about the time period. Oscillations per second is about the frequency. Then omega equal to pi f, that is angular frequency. This is about the natural frequency, natural angular. Next, damped oscillation. What is damped oscillation? Amplitude decreases with the time. That is known. See, you can see here. Amplitude decreasing with the time. That is known as the damped oscillations because of friction and resistance. Then, what is forced oscillations? External periodic force applied. The maximum amplitude with the help of external frequency and natural frequency. This is condition for resonance. When we applied external force, then that is called as the forced oscillation. And during this forced oscillation, natural frequency and applied frequency both are equal, and that is called as the resonance. You are observing that one when you are moving to the certain roads, your vehicle is getting a heavy sound. In that during that particular time, even the small parts of the vehicle also they are vibrating along with the motion of the vehicle, and there you will get large sound. That is known as the resonance. Natural frequency, it is combined with the artificial frequency or means of forced frequency, then that is known as a resonance. What is that? A resonance. Okay, introduction to the waves. Wave is a disturbance that transfers. Just we have what is wave? See, these are nothing but a wave characteristics only. Na? A wave is a disturbance that transfers energy through a medium. Wave is transport energy, not matter. Wave is transport energy, not matter. It is types of waves, that is about the mechanical wave as well as non-mechanical wave. Non-mechanical wave we will consider electromagnetic waves. Longitudinal waves, which moves the particles vibration parallel to the wave propagation, that is called longitudinal wave. I discussed this one in sound chapter. We will go for sound. Then transfer wave, the particle vibration perpendicular propagation of the wave, that is called as the transfer wave. Examples of the transfer wave is string waves and light waves. In transfer waves you will see crest and trough. In longitudinal wave we will see compression and refraction. Longitudinal wave sound is example of the longitudinal wave. So this is about the what we call longitudinal wave. This is about the transfer wave. What are the characteristics of the waves? So just now we discussed previously also, that is previous video. Wavelength, frequency, speed, amplitude, phase. These are the part of the characteristics of wave. What is wavelength? The distance between two consecutive crest and compressions or refractions and trough is known as the wavelength. Frequency, the number of waves passing a point per second is known as the frequency. Speed, V equal nu lambda. This is about the speed. Amplitude, maximum displacement. Phase, position in the oscillation cycle. That is about the phase. What is the principle of superposition? When two or more waves meet, the resultant displacement is algebraic sum of two individuals, that is y equal to y1 plus y2. This is known as the superposition. Superposition leads to constructive as well as destructive. Where in constructive you will see maximum amplitude, destructive you will see minimum amplitude. So this is wave y1, this is wave y2. Standing waves. What are standing waves? Formed by superposition of two identical waves traveling in opposite direction. You can see here one wave is moving in this direction, one is moving in this direction. During this particular transition they are superimposed. This superimposed is known as the standing wave. In standing wave you are able to see two different points. One is called node and antinode. What is node? Points where displacement is minimum, where displacement is, see, this is known as displacement is, here the displacement is minimum, that is called as node. Here the displacement is maximum, that is called as the antinode. This is known as antinode and this is known as node. Displacement, whenever, see, if you are taking, this is node, this is known as antinode. Okay, distance between two successive nodes is known as lambda by 2. Node and antinode is lambda by 4. Node and antinode is lambda by 4. Node to node is about lambda by 2. Doppler effect. The apparent change in frequency when there is a relative motion between source and observer. Observer and source, there is apparent frequency difference change, that is called a Doppler effect. Source moving to observer, as we know very well, you will get higher frequency. Higher frequency means higher pitch. Source moving away from the observer, lower frequency. What is the formula? That is about the apparent frequency equal to natural frequency into velocity by velocity plus or minus Vs. This is about the apparent frequency. Vs is nothing but velocity of the source. V is nothing but speed of sound, which is about 340 meter per second. You can see here, when you are moving away you will get lower frequency, when you are moving towards you will get higher frequency. This is about Doppler effect. Related to light we will see red shift as well as blue shift, that is related to light. This is related to the sound. Then MCQ series. In SHM, the restoring force is what? In SHM, the F is proportional to X. Force is always proportional to displacement. Force is proportional to displacement, but force always opposite to the displacement, so that F is proportional to minus X. Remove the proportionality. F equal to minus Kx. Your question is restoring force. So here the restoring force is proportional to displacement. Restoring force is proportional to displacement. For a simple pendulum, the time period depends on what? In the simple pendulum, the time period depends on the length, amplitude, but not depends on mass of the bob. Time period formula, T equal to 2 pi root L by G. It is the independent of the mass and small amplitude. Here amplitude with the small amplitude means less than 2 or 3. So here the simple one, small angles, here you have to consider theta is under 15 degrees. If you go with the more than 50, that will give the rank values. Okay, here the simple answer not depends on mass. A wave in which particle vibrate parallel to the direction of the propagation, that is about what? Tell me. You go with that one without checking this key, just you go for the answer. That is about longitudinal. So sound waves, compressional waves, sound waves, longitudinal mechanical waves. So sound waves and compression waves in spring are called as longitudinal wave. The speed of wave is given by, come on tell me without checking the answer. So here the speed of wave v equal to nu lambda. So that is about, nu is nothing but f lambda. Coming to fifth one, in a standing wave on a string fixed at both ends, the distance between two. you have standing wave. This is about the thing. Here one endpoint, this is one. The distance between two consecutive nodes, this is node, this is node. The distance between two successive nodes is known as lambda by 2. So that is about lambda. Nodes are represented, two nodes distance is represented by lambda by 2. Damping in oscillation causes. Why damping occur? So damping means what? Amplitude is reducing gradually because of friction, air resistance. So that is known as damping oscillation. Due to the energy loss due to friction and resistance reduces amplitude gradually, decreases amplitude gradually. That is known as the damping oscillation causes. Resonance occurs. What is resonance? Resonance is nothing but natural frequencies mixing with the natural frequency will be equal to the forced frequency. That's about the resonance. Here resonance occurs. Driving frequency equal to natural frequency. Driving means what? Applied frequency. Driving frequency is equal to natural frequency. That is known as resonance occurs character. Maximum energy transfer and amplitude resonance. So you can see the figure also. Coming to eighth one, Doppler effect is observed in, where observed? Doppler effect you are observed in sound waves as well as light waves. Apparent frequency change due to relative motion, that is called as Doppler effect. In astronomy, we will see redshift and blue shift, that is also known as Doppler effect for light. Constructive interference occurs. So here the answer is constructive interference occur. Interference is nothing but two waves are simultaneously coincide. So that is about the here phase difference even multiple of pi. Phase difference even multiple of pi, that is known as constructive interference. Interference is two types, constructive and destructive. Maximum one displacement constructive, minimum displacement is about the destructive. For mass spring system, frequency is what? For mass spring system, frequency omega equal to what? Root k by m. Here are asking about natural frequency. So omega equal to what? 2 pi f. So your question is, that is 1 by 2 pi root k by m. Nu naught equal to 1 by 2 pi root k by m. This is about the answer for the spring mass system. Electromagnetic waves are what? Electromagnetic waves are electric and magnetic field oscillate perpendicular to propagation direction. Electromagnetic waves are known as transfer waves, which are propagation is perpendicular. Propagation is perpendicular. In a system, velocity is a maximum. Where? That is about mean position. See, if you take simple pendulum, these are nothing but extreme position. Here velocity decreasing, so kinetic energy is 0. But here that will be coming towards this side, so that it is max. Kinetic energy is, the velocity is maximum at mean position. We have a formula also, V max equal to A omega. Okay, clear? Standing waves are formed due to, for what character? That is, they travel in opposite direction, they will creating standing waves. Is it right? When two waves are traveling in opposite direction, they create standing waves. Standing waves, that is, see, when wave is transferred like this, after striking a obstacle, it is bounce backing like this. So this is known as reflection. Reflection and superposition. Because of reflection, this is incident. This is about reflected. Incident and reflected waves of same frequency interfere to form a stationary. Incident wave reflected wave with the same frequency, they are superimposed, and because of this superimposed we got standing wave. That is answer A. If the length of the simple pendulum is double, its time period becomes, so we have t is equal to 2 pi root L by G. T is proportional to root L. Am I right? So that here it is, simple pendulum is double. So length is double, then time period automatically is what? That is about root 2 L. So proportionally, here it is 2 times, here also it will be 2 times. So that is root 2 times. I don't want to go with any complex and mixed, just I am going straight way, in simple way. When source of sound moves towards a stationary observer, the observer frequency, you are moving towards a source, the source is produced, you are moving towards the source only, and that is about the Doppler character. Here you are moving towards the source, that means you will get louder sound, so that the frequency is increasing. When source of sound moves towards the, when a source of sound moves towards a stationary observer, the observer frequency is increased. Observed wave bounce up, shorter wave, high frequency. The superposition principle applies to, superposition principle is applied to what? Superposition principle is applied to all types of the wave, or including even sound waves and light waves. Even sound waves and light waves. Then what is damping? Damping is nothing but reducing amplitude is called as the amplitude. So here this question is typically mistake, I will rectify in next session. Coming to 8.1, a node in a standing wave has, what it is, zero displacement. What is that one? Zero displacement. Coming to 9.1, for a transfer waves on a string, speed depends on what? Speed. For transfer wave, V equal to rho T by mu. This is called linear density. This is about tension. So it depends on tension and linear mass density. 20. Beats are produced due to, beats are produced. What is beats? Slight difference between two frequencies is known as beats. So beats are produced because of interference of two waves with slight different frequency. Slight frequency between two waves are creating beats. Interference of two waves with slight difference frequency is creating beats. The angular frequency omega in SHM is what? Omega equal to root K by M. 22nd one. Which wave does not require medium? Sound is a mechanical wave. Water is also mechanical, and seismic is also mechanical, but light is a non-mechanical and it is an electromagnetic wave, so they do not require medium. So sound, water, seismic, these are nothing but mechanical wave. 23rd one, in a closed organ pipe, fundamental frequency has, in a closed organ pipe, the fundamental frequency has node at closed end, anti-node at open end. Node, this is node, it is open, so at open end it is about anti-node, at closed end it is node. Coming to 24th one, if a frequency of wave doubles while speed remains constant, its wavelength. So that is about V equal to nu lambda. This is the question. Am I right? So here what is the question? Frequency of wave is double. This is double. So nu is like this. Nu is inversely proportional to lambda. Means opposite character. So velocity double, then its wavelength. So that will be off. Resonance can be, what is the use of the resonance, what is the damage of the resonance. So here that is about resonance is useful in musical instrument. Resonance is used in harmful effect like bridge collapses, Tacoma narrows. See, that is the reason soldiers are instructed not to perform march first on bridges, because that driving frequency, natural frequency, when they are coincide, a bridge may be collapse. Thank you.